Back in 2000, organizations deployed their entire business logic as a single monolith application. However, this suffered from the limitation in upgradation and scalability of this application. So if a new feature needed to be added to this application, then entire application code reviewed to see the impact of this new change. Moreover, if during peak times the usage of a specific feature out of this entire application is on high, then entire application needed to be deployed on additional machines, whereas all other features of this entire application were underutilized. So this was not cost effective. The response came in the form of an architecture and development style known as microservices. So microservices is a form of service-oriented architecture. So entire business logic is divided into different functions, and each of these functions are deployed as different microservices, and each microservice is deployed and developed independent of other microservice. And each of these microservice has its own application programming interface or API to invoke from other microservice. This resulted in faster development and deployment. Moreover, if a specific function is on high use, then only that specific microservice needed to be deployed on additional endpoints. So these are the endpoints on which each of the microservices is deployed, and these are also known as microservices endpoint. However, the orchestration or the coordination between different microservices is quite complex to implement the entire business logic. Now, a microservice needs to communicate with other microservice to implement a business logic, and this communication between microservices can be synchronous and asynchronous. So in synchronous communication, a microservice will invoke another microservice on which it depends, and then it waits for the response of that second microservice. So this synchronous is a limited approach due to the scalability issues. Moreover, errors can be found if the dependent microservice does not respond. Now the second communication style is asynchronous by using advanced message queuing protocol. So in this case, additional microservices can be added to the queue to return the response to dependent microservice, and this will increase the performance. Now with regards to the deployment architecture, a microservice can be deployed in a container, or it can be deployed over the cloud. So once we talk about the container deployment, so the container is an independent unit in which contains the entire runtime environment for a microservice, including its all libraries and all dependencies. So a microservice will run in a container irrespective of the underlying infrastructure. So in this entire container environment, there would be more containers. Each of these containers can contain a different microservice, and these all microservices will run independent of each other and also independent of the underlying infrastructure. However, all of these containers will share a kernel. Therefore, if there is a privilege escalation vulnerability, then it can impact the kernel, and thus if this vulnerability is there in a specific container, then it will affect the other container. Now, once we talk about the serverless or cloud-based deployment of microservice, so a microservice can be deployed on the cloud, and this deployment is called serverless microservice. And this is also known as function as a service, which is a variant of platform as a service. The only difference is that in platform as a service, an instance of the platform is always running, whereas in function as a service, a microservice will be running if it is required. So it is more cost efficient. Now, once we talk about this cloud-based or serverless microservice, so the separation of duties or separation of responsibilities for this microservice on the cloud should be very clear between cloud service provider and the microservice developer or microservice customer. So the cloud service provider or CSP is responsible for underlaying the platform and the infrastructure, whereas the customer is responsible for development and deployment of a specific microservice and also the access control. Now there are certain restrictions on cloud-based deployment with regards to the top execution time and also the code size. So the top execution time should be very less, and also the code size, because the top execution time of a microservice will add up to the overall orchestration of all microservice and overall business logic. So if this execution time has some overheads, then this will add up to the overall business logic. Moreover, the code size should be limited for better review and also for speedy upgrades in a specific microservice. Now, a microservice should be stateless. It means that the responsibility for managing the state of a microservice should be on a separate state management service to avoid the overhead of managing the state on a specific microservice. Once we talk about the security of microservice, so there should be a layered approach or a defense in depth security. It means that multiple controls should be implemented at various levels of architecture, starting from the network and then going towards application, and also starting from the physical security, then infrastructure, then network, and then the application. For example, the microservice endpoint should be hardened enough to avoid impact by any exploit which is coming out from a container. For example, privilege escalation vulnerability, if there is any in this microservice container, then it should not affect the endpoint, since this endpoint can be hosting other containers as well, depending upon the requirement, if this is a hypervisor environment. Moreover, there should be a patch management program and application security scanning, and also vulnerability management, encryption, and overall monitoring and logging. Now, with regards to the security, the application programming interfaces or API of a microservice is very important, because it is the single point of entry to a microservice. So this API should filter out any malicious access to a specific microservice. Moreover, this application programming interface of a microservice is used to discover that particular microservice, and it is also used to maintain session of a microservice, and also used to cache such sessions to increase the performance of a microservice. Moreover, this application programming interface is used for AAA services, that is authentication, authorization, and accounting related to a microservice. However, these AAA services should not be uh, overhead on a specific microservice. Rather, it should be offload to specific authorization and authentication servers. For example, the authentication can be offloaded to a SAML server or security assertion markup language server, or maybe to OpenID Connect. And authorization can be offloaded to an OAuth authorization server. So a user over the internet will first approach the authentication server, or will approach the authorization server. So first of all, he will approach the authentication server to get authenticated, and then he will approach the authorization server to get authorization to access a specific microservice. Now, a microservice endpoint should be restricted from direct public access by using a firewall. So the user can come to the DMZ server, and then from DMZ server, between DMZ server and microservice endpoint, there should be a firewall. So no direct access from public network should be allowed to the microservice endpoint. Now, with regards to cloud security, certain cloud service provider provides web application firewalls, and web application firewalls filter out any web-based or application-based attacks. For example, Open Web Application Security Project enumerate top 10 web application attacks. So such web application firewalls can prevent such web-based attacks. And moreover, microsegmentation by a firewall can also restrict access to a specific microservice. Moreover, in order to avoid denial of service attacks, certain cloud service provider implement content distribution networks. So content distribution or content delivery network add redundancy, and the static or semi-static data of a microservice can be offloaded to content distribution or content delivery networks, whereas the dynamic data can be served by a microservice. Now, uh, overall, in business logic, certain microservices are critical and certain are less critical. So, we need to classify which all microservices are more critical to implement more comprehensive control on such microservice. So, this was all from my side. Please stay connected. Thank you.